These are the notes for Thursday, November, or Wednesday, November 15th. We talked about orbital notation and electron configuration. This over here is your diagonal diagram. This is the order in which electrons fill the sublevels. So you always fill the 1s squared first, and then the electrons fill the 2s squared, and then electrons fill the 2p6, and then the 3s squared, 3p6. And then after this, they don't go in order. So you do not go to the 3D. You go down to the 4s squared, and then go up to the 3D, 4p, 5s, 4d, 5p, 6s, and then from 6s, you jump all the way up to the corner, 4f, and this one you're going to go all the way to the bottom corner. So 4f, 5d, 6p, 7s, and then 5f, 6d, 7p, and that's usually all the farther you would go, but you do have 6f, 7d, and 7f. But normally you won't go any higher than 7p. We did two things today. We did orbital notation. This is one way of showing how the electrons are arranged around the nucleus. And this way you show an orbital with a line. An orbital is where electrons are found. And we're going to show electrons with arrows. So this is an electron that's spinning up, and this is an electron that is spinning down. So electrons can have two spins, up or down. In order to be in the same orbital, electrons have to be paired up with their opposite. So you have to have an electron spinning up paired with an electron that's spinning down inside one orbital. Each orbital can hold at most 2 electrons, so either 1 or 2 electrons. So we started off with helium. If you look on your periodic table, helium has 2 electrons, atomic number 2. For all these, you start at the beginning of your diagonal diagram. So the electrons always fill the 1s squared first. So with this one, I wrote 1s squared, and then I drew one line because the s sublevel has 1 orbital, and then each orbital can have 2 electrons, so I put an up arrow and a down arrow. Helium only has 2 electrons, so that's all the farther I go. That's it. That's the orbital notation. Got 1s, 1 orbital, and 2 electrons. The other way you can write this is with the electron configuration. It's basically just a shorter way of writing this. It doesn't show the spins of the electrons. First, I write my sublevel, 1s, and then instead of lines and arrows, I just put a 2 to show that there are 2 electrons in the 1s sublevel. Next, we did oxygen. Oxygen is atomic number 8, so it has 8 electrons. You always start the same way. So I started with the 1s. I put 1s. I drew one line, and it's 1 orbital, so I put 2 electrons up and down. And then I did 2s. 2s comes after 1s on your diagram. All of your s's have 1 line, so I drew 1 line, and I have an electron spinning up with an electron spinning down. And then I did my 2p, because in my diagram, 2p comes next. The 2p has 3 orbitals, so I drew 3 lines. So at this point, I had 4 electrons. I want a total of 8 electrons for oxygen. So I need 1, 2, 3. I put the electrons spinning up first, 1 electron on each line. That's Hund's rule. Hund's rule says you put 1 electron in each orbital with the same spin before you go back and double up. So I did those 3. That brought me up to 7 electrons, and then I put 1 more spinning opposite, spinning down in the first orbital. We also wrote the electron configuration. So I did 1s and then squared to represent those 2 arrows down here. And then I did 2s squared for those 2 arrows. And then 2p, 1, 2, 3, 4, 2p to the 4th, 4 electrons. Then we did zinc. Zinc's a little bit longer, but as you can see, these are kind of the same thing over and over again. Zinc has 30 electrons, but you always start at the beginning. So I had to go back and start with the 1s still. So I did 1s, one line because it's an S and 2 arrows. 2s, one line, 2 arrows. Then 2p, just like oxygen, but I filled them all up because I have to go all the way to 30. Then after 2p, you go to 3s. All your S's have one line, 2 electrons. Then after the 3s, I go over to the 3p. All of your P's have 3 lines, so make sure you draw 3 separate lines, not one giant line, but 3 separate lines, and then your 6 arrows. Notice that I didn't put 3p to the 6th. I didn't put an exponent on the p. On orbital notation, your arrows are your electrons. Then after 3p, a common mistake is to do 3d, but notice you go down to the 4s. So I did 4s squared, and then I jump back up and have my 3d. All your D's, you're going to draw 5 lines, 5 orbitals. So I've got my 3D and my 5 lines. And I fill those up, and that takes me up to 30 electrons for zinc. And then I write the electron configuration. We did one more in class. We did antimony. Antimony goes up to 51. So you'll see that we went up to the 3D, just like the last one, just like zinc. Then from 3D for antimony, we went on to the 4p. So we did 3D, and then we did 4p. On the 4p's, on all the p's, you draw 3 lines, 6 electrons. And then we did 5s, and we just keep following the off ball. So after 5s comes 4d, and after 4d comes 5p. On the 5p, I use Hund's rule again, so I put 1 electron in each orbital with the same spin. And then this one I don't double up because at that point I'm at 51 electrons. And then notice orbital notation. On my last sublevel, I did 3p3 because I only have 3 electrons in there. Some people automatically put 3p to the 6th, but I don't have this filled with 6 electrons. It's only at 3. On the F sublevel, if you get to F, because it has 14 electrons, you draw 7 lines. You have 7 orbitals.